Good afternoon. Welcome to my presentation about my professional portfolio. My name is Andrew Thomas Hardigree, and this is what I would like to implement into my classrooms. First of all, here's my resume. From starting at the top with my education, I graduated with a class of 2017 from Texas A&M University Kingsville with a Bachelor of Science in Civil Engineering. And I'm currently part of the Master's of Science in Secondary Education with Teaching Certificate at Texas A&M University Corpus Christi with expected graduation date in 2022. So far, my experience inside a classroom has been limited to a substitute teacher role at Port Aransas Independent School District, which I started this year in 2021, and continue to be a substitute teacher there. Before entering education, I was a graduate engineer at a local engineering firm from 2017 to 2020. Along the way, I picked up a lot of relevant skills on software, including all of Microsoft Office, including Word, Excel, and PowerPoint, and also picked up proficiency in AutoCAD and AutoCAD Civil 3D from my civil engineering. And here is my professional resume attached. I blacked out some of the contact information for myself as well as some of my references, but this contact information is on my official resume, which I have handed out to schools. So when I enter my new classroom, I want the new parents of my new students to be prepared for who this new teacher is. And so I prepared a little introductory letter here that explains who I am, what I'm instilling in my students, my teaching philosophy, as well as what culture I want in my classroom. And to read it for y'all, since I'm kind of blocking the top portion here, I'm a new math and science teacher here at Blank High School, and I will be teaching my students about physics, algebra, and upper level mathematics. Before becoming a teacher, I was a civil engineer and had a passion for informing and teaching the public about projects. And I'm now using the background to teach my students about the wonderful world of math, science, and engineering. These aren't easy subjects, but it is my belief that effort goes a long way for success, and I encourage my students to express to their parents or guardians what they learn each day, whether it is common sense or something brand new. Everyone who wants to succeed can succeed, and I will help every student in any way they need. I run a no bullying classroom. My classroom is a safe environment where everyone is welcome. I take bullying and harassment very seriously, and I will work with my students to eliminate toxic behaviors. I do believe that all students are good kids, and I want to be the teacher that helps guide them towards a successful path. I look forward to teaching your children, and if you have any questions, please feel free to reach out. Thank you. I want to share a couple quotes that kind of inspired me to take up a math background and things that I want to instill upon my students when they're learning about mathematics and physics. So the first quote is from David Hilbert, who was a German mathematician who was born in 1862 and died in the early 1940s. And he says, "Mathematics knows no races or geographic boundaries. For mathematics, the cultural world is one country." Galileo Galilei wrote, "Nature is written in mathematical language." And a source that wants to be anonymous said, "Mathematics may not teach us to add love or subtract hate, but it gives us hope that every problem has a solution." And this goes well with my classroom culture as well as my philosophy. As we get into my goals and targets, I want students to learn math not as just simply numbers on a page, but it's its own language, and it's language behind the physical sciences of the world, as well as the universe. And if students get this in their head that they're just basically learning a universal language, they will succeed. And I want to explain to my students what the real world benefits of learning math and science are. It's very easy for someone to see a problem in a textbook and say, when am I ever going to use this again? I want to explain to them how this is used, why it is used, and when they might use it again. I want to instill that there is an importance of both scientific and self-discovery in my classroom. Students need to learn how to discover solutions not only on their own independently, but also in groups. Work well in groups, work well independently. And they will discover new ways of solving mathematics and physics equations on their own, and that will prepare them for a lifetime of math and sciences ahead if they choose to go that route. Most of all, I want all my students to see that there is more of a fun side to studying math than they might have had before. Math, when I was growing up, math was all about numbers on the page, just doing worksheet after worksheet over and over again. And it was kind of hard to see the fun that mathematics could be from that. So I want to incorporate real-world physical examples into mathematics and show them that this can have real-world impacts, and it can be fun while you're learning it. I also plan to give activities that get us acquainted with one student to another student, as well as teacher to students. So at the start of every class, I'll bring up an exercise that helps them get prepared. When coming into my class, I want the students to feel relaxed. There's a ton of stress on students these days, and the most important thing to do is, when being in the classroom, is to relax and be prepared to learn. So to do that, I picked up during my time as a student, there are breathing exercises where you sit silently for a minute, maybe 2 minutes, and just breathe and not do anything. And it just calms, relaxes, and gets you ready to learn what you need to learn. Other examples that I might implement include giving time to draw or doodle, read or write, and especially write about how they're feeling that day. These seem like elementary school tasks and probably don't belong in high school, but give it a couple minutes to just doodle an image or let students write about how they're feeling on that given day. Really lets students relax and gets them prepared to focus on what's ahead. So something I picked up during my engineering days was, whenever I had to give presentations, I always try and incorporate jokes, as those are what kind of stick to people. And so I would like to incorporate school-appropriate math or physics jokes or memes that I can use at the start of my presentation in class, and then move on to the lesson. And the jokes or meme would involve at the start of the lesson would have to do with that said lesson, and after class they should be able to figure out why that joke was funny, or at least funny to me. Or they might not find it funny, but it might be a good way of getting a connection with the students. So the first assignment of new school year, I personally just give them a handout to fill out that just gives me an idea of what their interests are, where they lie, and are they involved in extracurricular activities after school? Are they athletic? Do they run cross country or track, play basketball, football? What do they like to do? That way I can form what are known as moments of genuine connection. During another one of my classes, we read an article, or I should say listened to a podcast about teachers generating moments of genuine connection with their students. And these are just brief interactions, or really just chats with students that don't necessarily pertain to school, but they just teachers reaching students on a personal level, and just developing a relationship of trust between students and teachers. So to give an example of a joke or a meme that I would incorporate, so this has to do with teaching about prime numbers, which prime numbers are abundance in any level of mathematics. So, and when we think of prime numbers, we most think of the odd prime numbers, because the vast majority of Prime numbers are always odd. But here we have 3, 5, 7, 11, 13, then the number 2. The number 2 is actually odd, and the other prime numbers don't seem to really like that, but it's true. Number 2 is a prime number and it's not odd. So learning activities. Activities assigned can be hands-on experiments or worksheets or a mixture of both. Whenever I hand out worksheets, they'll be engaging and are intended to develop critical thinking skills. These aren't necessarily just cut and paste from a textbook, but require students to really think about it, really think about the question being asked and how to go forward. Unless otherwise stated on the questions, students should work independently, but they shouldn't be afraid to use resources such as books, their parents or guardians, or even the internet. The internet is a great resource to use, but so much of our days is just using the internet as a question and answer machine. So we can't have our students just look up answers. We have to have them have that critical thinking skill to know how to use that resource. And also just to display their knowledge and understanding, just routine quizzes and tests in a non-aggressive environment. Just let them put down the answer that they think is correct, and whether it counts as a grade or not, it shouldn't matter in the end. Just let me know what their skill level is, what their knowledge level is, and then I can teach them more effectively. So here's a sample of a learning activity that I have here. So this one I came up with, and so this has more to do with a physics class. So the first question states, using your own words, define terminal velocity. And so if I was a student looking at this, I would say terminal velocity, that's roughly when air resistance equals out with the gravitational force of pulling an object towards the earth. And so that's about terminal velocity. And so then we go through, and then there's an experiment of dropping a flat sheet of paper and a crumpled up piece of paper. Now I chose these because in other experiments, when, say, I was younger, we would use something like a tennis ball and a feather. Not every student may have access to a tennis ball and a feather, but thanks to school resources nowadays, most students are now given a notebook to take home with. So they should have at least 2 pieces of paper, and the experiment can still be conducted in such a manner. Then, using a stopwatch or slow motion camera, time how long it takes for the flat piece of paper to touch the ground and for the crumpled up paper to touch the ground. Those are questions 3 and 4. So stopwatches and slow motion cameras, most slow motion cameras now are built into phones. Stopwatches are built into phones. They can even use something like a timer on a microwave or an oven, and it still works. And then we go into the why of the experiment. So this is where we get into the critical thinking. Why does one object touch the ground faster than the other object? And then we also have prediction. What would happen if we conducted the same experiment on the moon? I also included that after the prediction, they should look up a video of the Apollo astronauts conducting a similar experiment and see how their prediction holds up to what the Apollo astronauts did. And finally, we have question number 7. Without aid from a book or computer, in simplest terms, what is the definition of flight or flying? And what is the definition of an orbit? And I also stated that we would go over that in the class tomorrow. So that would lead into what our next lesson would be about, which would assumingly be the physics of aerodynamics, which is something that high schoolers do learn nowadays in their physics classes. So I hope you all enjoyed this little presentation I put together for my professional portfolio. And I hope this is useful to anyone who wants to use it, as giving ideas as to what or how to incorporate this into an effective teaching environment. Thank you.